Good morning, my students. I am Ali Akbar, senior teacher of English medium senior section, Milestone School and College. Today, I am here to talk about chapter 1, that is pattern for class 8. And today, I will talk about 5 MCQs that are very important for JSC examination. And I hope by solving these 5 MCQ questions, you will get so many information so that you can beat any kind of or maximum types of MCQ questions. My dear student, this is part 1 for MCQ solving or MCQ solution of chapter 1. So let's move to the problems. Dear students, in the whiteboard, I have already written 5 MCQ questions. Here you see in number 1, which one is the magic square of water 4? Dear students, this is very important MCQ for the JSC examination. Okay, in your textbook, if you open the book, and I hope if you have the textbook with you, then you will be benefited more. Okay, in your page number 6 and 7, basically in page number 6, you are given formation of magic square. Okay, fine. A magic square of water 3, another one is magic square of water 4. Okay, you have learned that magic number of water 3 is 15 and magic square of water 4 is 34. But in page number 7, in activity number 2, you are asked that to construct a magic square of water 5. Okay, so if the question comes that what will be the magic number of square of water 5, then what we will do? We have maximum times seen that our students just memorize water square order of 3, square order of 4 and square order of 5. But remember, there is a very interesting formula to find out any number of square order 3, 4, 5, etc. Okay, the formula is like that. You see, n into n square plus 1 and divided by 2. I think you can see very clearly the formula is like n into n square plus 1 divided by 2. Here, what is n? N is the square of water. Say square of water, if it is 4, then in the place of n, you will write 4. If it is magic square of water 5, then n will be 5. If magic square of water 6, you will write 6 in place of n. So here, which one is the magic square of water 4? So according to the question, here the value of n equal to 4. So you write 4 and here 4 square plus 1 divided by 2 equal to 4 into, you see, 4 square, that is 16. Okay, 16 plus 1 divided by 2, that is 4 into 70 divided by 2 equal to, okay, 2, that is 34. That is the magic square of water 4, and for magic square of water 4, the magic number will be this 34. So if you are asked which one is the magic square of water 5, 6, 7, then what you will do? Just in the place of n, you will write 6, you will write 7, you will write 8. So I think from now onward, every student will be able to solve any kind of MCQ related to magic square water, right? Okay, fine. So let us erase this one, and now let us talk about Question number 2. What type of number pattern 0, 1, 1, 2, 3, 5, 8, 13 is? Okay, let us write 0, 1, 1, 2, 3, 5, 8, and then 13. Okay, fine. You see 0 plus 1 equal to 1. This one, that is 0 plus 1, the sum of 0 plus 1, the sum of 0 plus 1 equal to 1. Again you see the sum of 1 and 2 equal to 3. Again you see the sum of 2 plus 3 equal to 5. Again you see the sum of 3 plus 5 equal to 8. That is, here if you very closely observe, then you will see that the relation of the number of list is like the sum of previous two numbers equal to the next number. Okay, again I am telling, the sum of previous two consecutive number equal to the next number. Say, think here 5 plus 8 equal to 13. That is the sum of previous or preceding two numbers equal to the next number. My dear students, try to understand when the number patterns show this type of sequence, then this is called Fibonacci series or Fibonacci number list or Fibonacci number pattern. Dear students, Fibonacci, the name is very interesting and a little bit exceptional. Okay, say I am writing here, okay, Fibonacci. Okay, you see Bonacci. Okay, Bonacci, Fibonacci, and you will be very glad to know that the word Fibonacci means son of Bonacci. Bonacci is a place of Italy. Okay, that is, Fibonacci was the mathematician of Italy. Okay, clear? That is why his name is Fibonacci. Okay, fine. So, according to in Fibonacci first time, okay, observed and made this pattern. That is why, according to his name, this type of number pattern is called Fibonacci number pattern. So, my dear students, I hope you have understood about Fibonacci number. Okay, fine. Now let us think about number 3. Okay, number 3. In number 3, how many prime numbers are there from 1 to 50? Okay, fine. You see prime, okay, prime numbers, or think prime number. Okay. Now let us first think about actually what will be the prime number or prime numbers. Okay. Remember, first point is that prime number, think this is Pn, prime number will be of course greater than 1. Okay, always try to remember, keep in your brain that prime number always will be greater than 1. Okay, fine. So you have got one point. Then another point is, okay, another point is there will be no factor, okay, except 1 and itself. Okay, clear? So prime number will be greater than 1. Okay, 1 point. Another one is, hey, prime number, in prime number there is no factor except 1 and itself. Okay, let us try to understand. Okay, fine. Now you see here I am writing 1, then 2, then 3, then 4, then 5. Okay, fine. Then you see 1 is greater than 1, so forget this 1. Okay, fine. Now let us start from number 2. You see 2, that is 1 and 2. Okay, I mean 2 has 2 factors, that is 1 and itself, and without or except 1 and itself there is no factors of 2. Okay, fine. So you see greater than 1, of course 2 is greater than 1, and then you see no factor except 1 and itself, that is 2. Okay, so as 2 is greater than 1 and 2 does not have any factor except 1 and 2 itself, that is why 2 will be prime number. Now you see 3. Okay, 1 and 3, and you see 3 does not have any factor except 1 and itself, so 3 will be a prime number. Okay, now my dear students, let us analyze a little bit better number. Think about 21. Okay, 21, that is you can think 1 into 21, you can think 3 into 7. Okay, so it is seen that 21 of course greater than 1, but you see except 1 and itself it has other 2 factors, 3 and 7. As 21 has factors other than 1 and itself, so 21 will not be a what? Prime number. Now think about 23. You see 23, 1 into 23, and there is no other factor, so 23 will be a prime number. So my dear students, I think by analyzing these points you have understood which one will be a prime number and which one will not be a prime number and which one will not be a prime number. Okay, now let us first talk about the question number 3. How many prime numbers are there from 1 to 50? My dear students, in your textbook page number 2, you are in caption 1.2, patterns of natural numbers determining prime numbers, you are given a sieve that is filter like something, sieve, and it is called the sieve of Eratosthenes. And if you observe the sieve of Eratosthenes, then very easily you can find out number of prime numbers from 1 to 10, 1 to 20, 1 to 50, 1 to 100. Okay, so I will suggest you as a teacher, okay, to save your time in the exam, what you will do in your textbook, okay, what you will do, you will just write, jot down, okay, say from 1 to 10 you will find 4 prime numbers. From 11 to 20, you will get 4 prime numbers. From 21 to 30, you will get 2 prime numbers. Okay, so after observing these sieve of Eratosthenes, you can write any answer of the question, like say how many prime numbers from 1 to 50 and how many prime numbers are there from 1 to 100, from 1 to 20. Okay, say for example, if you see then you will find from 1 to 10 there are 4 prime numbers. Okay, who are they? Say 2 is a prime number, 3 is a prime number, but 4 is not a prime number because 2s are 2, that is 4 has factors than 1 and itself 4. Then 5 is a prime number because 5 does not have any factor except 1 and 5 itself. Then you see number 6, 2s are 3, that is 6 has factors more than 1 and 6. So 6 is not a prime number. In this way you will find that from 1 to 10 there are 4 prime numbers, that is 2, 3, 5, 7. And then from 11 to 10, 20, you have 4 prime numbers. And in this way, by calculating, you will see that from 1 to 50, there are how many? 4 plus 4, 8, 8 plus 2, 10, 12, 15. That is from 1 to 50, there are 15 prime numbers. So, by analyzing the sieve of Eratosthenes at page number 2, you can answer any kind of question related to prime number. My dear students, along with this type of question, there is another type of question sometimes comes. Say, which one of the following is a prime number? You will be given some numbers. Say, think about 21, 23, okay, and then think 29. You see, 23, that is 1 into 23, and there is no factors, and 29, that is 1 into 29, and 21, that is 3 into 7. That is, you see, 21 has more factors other than 1 and itself 21. So 21 is not a prime number. But here you see 23, it does not have any factors except 1 and 23. 29, it does not have any factors except 1 and 29. So if the question comes like which one is not a prime number, then I think very easily you can find out. Okay, fine, thank you. So I think you have already got the answer of question number 3. Okay, now let us think about question number 4. This is also related to prime number. Which one is the smallest prime number? As 1 is not a prime number, so of course 2 will be prime number because 2 does not have any factor except 1 and 2. So 2 will be the smallest prime number. Okay, fine. Thank you. Now you see number 5. Okay. In number 5, you are given 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 equal to what? You know, in your textbook at page number 4, my dear students, you see I give you the reference of textbook once again. It's because whatever you do, remember, always try to follow your textbook. Okay, fine. Now in your textbook at page number 4, you are given one formula for sum. Okay, fine. Let me erase it. Now you see sum equal to, okay, first number. Okay, first number, shortly I am writing, plus last number, bracket closed, into number of terms or number of numbers. How many numbers here? 1, 2, 3, 4, 5, 6, 7. So 7. Okay. Then divided by 2. Then you see first number here 3 plus last number is 9, then into 7 divided by 2. You see, this is 9 plus 3, 12 into 7 divided by 2 equal to 2 goes to 12. Okay, 6 times. So 6 are 7. This is 42. So in this way, you can find out the sum of any consecutive natural number. So my dear students, actually in this short class, you have understood how to find out the magic number of different types of magic square of water, and then you have got idea about Fibonacci number, and then you have got idea about prime numbers. Okay, and you have got idea about the what sum, that is determining the sum of consecutive natural number. So my dear students, I hope if you follow this 5 questions, so maximum, I think maximum student questions will be solved by you. Okay my dear, now once again I want to share one thing.